It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Southern University. Live the dream.
Good morning, everyone. A very warm welcome to each and everyone present here at Lanodaya Day 1. Now, I would like Dr. Srinath to take over from here. As for the first session, you guys have mathematics. So, Dr. Srinath sir will be teaching mathematics to you guys. Srinath sir, you can start presenting, sir.
Yeah, good morning, everybody. Dear students, welcome to this season 2 of Larnodhaya. Yesterday, we had a wonderful orientation program. So, initially, today being the first day, I would not prefer to go fast in the topic that is being allotted to me. Today, I'll be covering the relations and functions. And inverse trigonometric functions may be little difficult today, as being mentioned there. That will be taken in a different session. Well, already you have studied this relations and functions in the first year as well as the second year. Okay. So, what is the basis for this relations and functions? The basis for the functions and relations is the good knowledge of the set theory. So, you should know the sets, the intervals, etc. Then, afterwards, we talk about the ordered pair. Then, what is a Cartesian product of two sets? Then, how a relation is being defined, then how a function is being defined, and again you come back to the second year syllabus where you will learn more about the functions, the types of functions, and what is a bijection, what is invertible composite function, etc. Then followed by the again the equivalence relation, or prior to that you study about types of relations, etc. Okay, we shall go to these problems. I'll be doing the screen sharing now. Yes, I hope the screen is clear to you. Fine. My dear students, some of the important things. And I write like this, A comma B. So this is an ordered pair. Ordered pair. Then when I write A cross B, what does it mean? It is just set of all A comma B such that A belongs to A and B belongs to B. A small quick revision I would like to do, okay, before taking up the problems. Now, what is a relation? A relation R is a subset of A cross B. And when I say subset, empty set is a subset of every set. So therefore, a null set is also a relation called as the null relation. Suppose A cross B, if you take A cross B, every set is a subset of itself. So A cross B is a subset of A cross B. A cross B itself is one relation. What we call it as the universal relation. Then you would have studied what is this R inverse. What is this R inverse? The set of all B comma A such that A comma B belongs to R. This we call it as the inverse relation. And in relation, you know what is a domain and what is the codomain, what is the range. So in case of an inverse relation, it gets interchanged something. Now, apart from that, some relations qualify to become functions. So what is this function means? Function means the notation. We use this F is a mapping from A to B. We call this as the domain and we call this as the codomain. What is so special about this function? That is, every element of A is associated to a unique element in B. That means no two elements can go to the same element and no element can be left over. So that's the speciality of a function. Okay, again we talk about range and other things. Now, after that, we have already studied some graphs of functions also. Okay, what are those graphs of functions? In fact, like, you have studied what are the mod x graph. What is this mod x graph? How does it look like? It's a V-shaped graph like this. So this is the x-axis, y-axis. Okay, so it completely is above the x-axis. It touches the x-axis at the origin, in fact. Okay, and this is symmetrical about the y-axis. So this mod x, we also know, should be taken as x when x is greater than or equal to 0, and it is minus x when x is less than 0. And you have also been introduced to greatest integer function. So that greatest integer function is a staircase function, just like a staircase it looks like. Okay. What does greatest integer function do? It always returns an integer value. Whatever the number that you give, it always returns the integer value that is less than, or that is the greatest integer less than or equal to x. Some important things that you need to do. For example, if I give you something like this, what is greatest integer of 2.1? You will say it is 2. And if it is greatest integer of minus 2.1, so it is minus 3. Now, there's one important. Whenever x is not an integer, you should observe this greatest integer function plus greatest integer function of minus x will always be equal to minus 1. So sometimes in some questions, this may be useful to you. And apart from that, you have learned about um, the graph of x square, sine function, and etc. Okay. And let me come back to the second year portions. We talk about the relation on a set. What do you mean by relation on a set? Any subset of A cross A, which we call it as the relation on the set. And here we talk about reflexive relation, then we talk about symmetric relation, then we talk about transitive relation. When all the three happens, then we call such a relation as an equivalence relation. There's some beautiful example I wanted to give. Normally, when a set A is given, they'll ask you, what is that with minimum number of ordered pairs? What is that? How to make it as a equivalence relation? Then I'll talk about something known as an identity relation. This identity relation, maybe I'll just indicate this as IA. Suppose if A is having, say, A, B, C. What is this identity relation? So this will be A comma A, B comma B, and C comma C. Well, if you observe this, is it reflexive? It is reflexive, yes. Is it symmetric? Yeah, you will be wondering what is this A comma B is not there, then how can you find B comma A? But when you see A comma A, this A comma A, if you interchange, it is still there. So therefore it is reflexive. See, if you interchange this, it is still there in the same set. So therefore it is reflexive. Now, how do you check this transitive property? If you are having A comma A, take the Xerox A comma A. A is linked to A. Okay. So this A and A should be related. Is it here? It is here. So therefore, it is transitive also. So therefore, if we are given any set, how do you form an equivalence relation with minimum number of ordered pairs? Means it will definitely be what is known as an identity relation. Okay, these are some of the things. Then equivalence relation is over. Then we go to, once again, functions. What do you know about functions? In that functions, we talk about real valued functions. What do you mean by real valued functions? We talk about something like R to R, or probably an interval of R in both the cases. So this we call it as what is known as a real valued function. Okay, we will not talk about 1 and other things with respect to real valued. Any general function also we can discuss about 1 and on to. See, 1 function. So that means, suppose if you are having something like A, B, C, and here you are having 1, 2, 3, 4, set A to set B. This function, is it 1? Yes. Why? Because there is no element in B which has got more than one pre-image. So therefore, this is a 1 function. If it is not 1, it is also referred as an many one function. Suppose in this, I will give one more example. Suppose if you are having A, B, C, 1, 2. Here if you observe, this function is referred as an onto function. Why it is called as an onto function? No element in B is being left over. So that means here the range happens to be the codomain. Okay. So therefore, this is an onto function. If it is not onto, it is called as an into. Now, what is more important for us is a function which is both 1, 1 and onto. A function which is both 1, 1 and onto is being referred as a bijection. What is the advantage of a bijection? It becomes invertible. So invertible means you can find always an inverse function. So these are some of the things. Apart from that, I think you have already learned the composite functions, the binary operations, etc. So I think I have spent enough time on this synopsis, which you have already done. You have already completed your board exams. So therefore, I do not want to again repeat the same thing. We shall quickly go to the problems one by one. I think you all have received the material in that there are about 50 problems. It is not possible for us to discuss all the 50 problems in this session of 2 hours. So therefore, some problems has been chosen for discussion. And of course, if you have any doubts, you can get it clarified via mail or chat box or however DSU. You can keep in touch with them. They'll pass the problems or the questions to us. We'll definitely for that try to address it. Okay. I hope we are ready to go for problems. Yes. Yeah. One by one. I hope the screen is very clear to you. Yeah. Here, f is a function from x to y defined by f of x is equal to sine x. What is given? It is 1, 1, but not onto. So if x and y are respectively equal to, so what is that? How do we choose this? See, you have been given something like this. Let me take. Say, for example, it's given sine x, say minus pi by 2, pi by 2. And here it is minus 1, etc. up to 0 to 1. Okay, this function, if you take sine x, this will be definitely, what is that? It's a bijection. It's a bijection. But we want this to be 1, 1 and not onto. So what is it I can do? See, suppose if I'm going to take only these type of arrows, if I fix, okay, I'll not take this into consideration. Only from 0 to pi by 2 I'll take. Did you observe that? This is your x and this is y. So this function is 1, 1, but not onto. So we have cut the domain into size. So that means it is from 0 to pi by 2 and 1 minus 1 to 1. So this you should observe from minus 1, that is 0 to minus 1 into 0. It does not have any pre-images. So therefore, the answer is this option C. I hope you have followed. Can I go to the next one, please? Yeah, since you are all muted, so I'll not be able to get your response. Okay. So if there is anything, I think our coordinator, uh, Akhilesh, will help us. Okay. Shall we go to the next one, please? Okay, let me go to the next one. Yeah, here's the third problem. I have selected some problems for working in the class. F is a function from R to R defined by f of x is equal to mod x. Then f inverse of x is equal to minus x. F inverse of x is 1 by mod x. The function f inverse of x does not exist. F inverse of x is 1 by x. See, as I told you the beginning, if you take this mod x graph, so if you take this as minus 1 goes to 1, and this 1 also having its image 1. So here observe that this f of minus 1 is 1, f of 1 is also 1. So therefore, from these two, we can say that it is not 1, 1. Not 1, 1 means not a bijection. So if it's not a bijection, then it cannot be invertible. So the inverse function does not exist. So the answer is the C option. The function f inverse of x does not exist. This is the right answer. Okay. So most of the time throughout our session, it's not the stereotypic, the board problems that we are going to discuss. We are going to discuss the concept, how do you understand, how you can solve the problem in a different way. The concepts won't change, but the way that how we look at the problem will change. Well, let us come to this problem. F is a function from R to R. F of x is equal to x cube. So what is being asked is f inverse of 8. Suppose if you take f inverse of 8 as x, then you will write 8 is equal to f of x, which is equal to x cube. So therefore, you will say your x will be equal to 2. So therefore, your f inverse of 8 is this set 2. But you must be wondering why this option D is also given. If you observe this, 2 cube is also 8. 2 omega whole cube is also 8. And 2 omega square whole cube is also 8. Then why don't we choose this answer B? We cannot choose this answer B because the function is from R to R. Had it been f from C to C, where C is the set of complex numbers, then we could have chosen D as the better option. I hope you're able to follow this. So kindly note, understand these problems. Okay, there may be the options may be little tricky. Okay. So the answer for you is this C. Yes. R is an equivalence relation defined on the set containing 6 elements. The number of ordered pairs that R should contain is. Just now I introduced that small concept, that is you have to write the identity relation. So it consists of 6 distinct elements. So therefore, probably if you take this as A1, A2, A3, A4, A5, A6, then it will be A1, comma A1, A2, comma A2, up to A6, comma A6. So therefore, it will be having the minimum number of ordered pairs as 6 only. It's a very simple question. Yesterday in the orientation, I was talking about the time complexity problems. Some problems, less than 5 seconds, some problem in, say, about 15 to 20 seconds or something like that. So this is what, of course, when we are teaching to make you understand, we take more time, the teachers, but when students actually appear for the exam or when they take up the test, they will be taking less time than us. Yeah. Define a relation R on A 1, 2, 3, 4. X is related to Y if X divides Y. Then R is. See, every number divides itself. Therefore, it has to be reflexive. Say, for example, 2 divides 4, but 4 doesn't divide 2. So, therefore, it is not symmetric. But however, you please observe 1 divides 2 and 2 divides 4 and 1 divides 4 also. So it is transitive. It is reflexive and transitive. So therefore, the answer is this option A. Yeah, here we are talking about the domain of f of x is equal to sine inverse of log of x by 2. Okay, even though we are doing this problem on the relations and functions, somehow an inverse trigonometric function also has crept in. I'm happy about it. Well, sine inverse x. If you take sine inverse x, that's x must be lying between -1 and +1. So therefore here sine inverse of something, that is log x by 2 to base e, that should lie between -1 and +1. So I'll write log of x by 2 to base 2. This should lie between -1 and +1. So that means 2 to the power of -1 is less than or equal to x by 2. This is less than or equal to 2 to the power of 1. That is raising throughout by, what is that, 2 to the power of that. So that means here, so 1 by 2 is less than or equal to x by 2, less than or equal to 2. So therefore, you get 1 less than or equal to x, less than or equal to 4. So therefore, straight away, you can conclude the answer is C. I hope you have followed this. There's also some quick problems. Normally, you don't get complicated problems in relations and functions. Normally, these relations and functions, you can do it with ease, save a lot of time, unlike, differentiation, integration, etc. Even in integration, differentiation also, there are ways of doing. Yesterday, Professor Mallikarjun did show you a small shortcut on this differentiation, implicit differentiation, by using partial differentiation, which will be taught a little later. Okay. F is a function from R to R defined by f of x is equal to 2x plus 3 f inverse x. This is a very, very simple problem. This is a board related problem, but still I just want it. Whenever you are finding the inverse function, what you do, see, let us take this 2x plus 3 as equal to y. You solve for x. What is that x you are going to get? y minus 3 by 2. This f inverse of f, see, you are writing f of x is equal to y. So therefore, your x is equal to f inverse y. This much of detailing is actually not necessary in CET, only with the objective of making you understand, reach out to all the students. I am doing little detailed work. This may not be required. So this is f inverse of y. This is equal to y minus 3 by 2. So replace this y by x. F inverse of x is x minus 3 by 2. So this much of detail work is not necessary. What you have to do is just 2x plus 3 is equal to y. Solve for x. Okay, it will be in terms of y. That y you replace it by x, you get the answer. So the answer is this. The answer is B. I hope you followed this. This being the very first class, I do not want to scare you by going fast. Any feedback from the students right now so far? Is it smooth going?
Sir, there is a question for you. Miss Purnima RB has asked to repeat the ninth question.
Ninth question.
Yes, sir.
Yeah. Yes, Purnima. I'm just repeating this for you. Maybe it could benefit all others also. Okay. See, it's a known fact that if you are having something like y is equal to sine inverse something, this something is there, no? This something should lie between -1 and +1. Okay, what is that something now? That is log x by 2 to base 2. This is lying between -1 and +1. Okay, 2 to the power of -1 less than or equal to 2 to the power of log x by 2 to base 2 is less than or equal to 2 to the power of 1. Is that okay? Now, you must be knowing this. A to the power of log x to base a is x. So therefore, is 2 to the power of -1 less than or equal to, it is x by 2 less than or equal to 2. I multiply throughout by 2. So if you multiply by 2, 2 to the power of -1 into 2 is 1. 1 less than or equal to x less than or equal to 4. Please don't bother about the handwriting and other things. Okay, in CET, the presentation is not at all required. Okay, and I suggest, the students should come to the class with a book also, a notebook, so that you can write down whenever I work. That will be better. Huh? So you just can't watch and learn everything. Okay, you need to write down also. Then let there be some sort of a seriousness in the class. Even though these classes are for free, it should not be taken very lightly. They have taken a lot of efforts to teach you. They have prepared the material. The best of the teachers have been drafted. It is no less than any other coaching center. Okay, please. I think, Akhilesh, I think I can go to the next one.
Yes, sir.
Yeah, fine. This is an interesting problem. 12th one. The range of the function f of x is equal to sine of greatest integer x. And of course, here x lies between -π/4 and +π/4. So we are talking about the range. What are the values that the function can assume, can attain? So let me take like this. For example, this -π/4 to +π/4 if you take. So there's a 0 in between, minus pi by 4 plus pi by 4. These are the values that x can take. Okay, there is a function involved, greatest integer function. Please, every one of you, please do concentrate. This minus plus pi by 4 is, what is that? 3.14 by 4. I think slightly greater than 0.75, if I am right. And this will be minus 0.75 something. So therefore, I think this is the 0.75 mark. I mean, minus 0.75 mark. And here it is the 0.75 mark. See, you know that if it is less than 1, this greatest integer function, okay, its value will become 0. At 0 also it is 0. Between minus pi by 4 and 0. So what is this? Its value will become minus 1. I hope you are convinced. Once again, I repeat, between 0 and 1, the greatest integer value will be 0. Between minus 1 and 0, the greatest integer value will be minus 1. So therefore, now we are having this function, sine of greatest integer function x. So what is this sine of minus 1? That sine of minus 1 will become minus sine 1. And what is 0? Sine 0 is 0. So this function can take this function f of x is equal to sine x when sine of greatest integer x, when x lies between minus pi by 4 and plus pi by 4, can assume these two values only. What are that? 0 and minus sine 1. So therefore, the answer is simply this D. Let me see if there is any reaction for this problem. Akhilesh, is there any response for this?
No, sir.
No problem. I think they are fine. Good.
Sir, Mr. Sharan wants the explanation again for question number 12, sir.
Okay. Fine. No problem. Mr. Sharan, is it? Okay. Please do listen. See, your first thing is the domain has been defined. What is the domain has been defined as? Something like from minus pi by 4 to plus pi by 4. The value of pi is 3.14. So therefore, pi by 4 will be actually slightly greater than 0.75. So here also, this will be minus 0.75 will be here. Now we are talking about greatest integer value of x. The greatest integer value of x, when x is between 0 and 0.75, okay, between 0 and pi by 4, this greatest integer value will become 0. Here, when x lies between minus pi by 4 and 0, its greatest integer value will be minus 1. Now, what we are having is sine of greatest integer x. So that means you have to take the sine of this, we have to sine of this. So when x is lying between minus pi by 4 and plus pi by 4, your greatest integer value is taking only this minus 1 and 0. And sine of minus 1 is minus sine 1. And sine of 0 is 0. So therefore, these are the two values that f of x can take. So therefore, the range is simply this 0 and minus sign 1. I think I am sure now you are convinced. Yeah.
So
Very
there are
good.
two more questions.
Ah.
One is from K. Prajwal. His question is, sir, should it be bracket minus sin 1 comma 0?
Which, can you unmute the participant? If unmuted, you can ask the question directly now.
Sir, I don't think so. I can unmute the participants.
Okay. Okay, I'll clarify. Answer is it's a discrete value. So it can only assume minus sign 1 and 0. So therefore, here this is a set consisting of two values. So 0 and minus sign 1. So that is the answer. That is the set. So this element is there, this element is there in the range. So therefore, the answer is this. It's not an interval. It's not an interval. Yeah. I think I can go to the next one, please.
Sir, there's one more from
Please.
Tejasvi Surya. Her question is why they took 0.76 and 0.75 in 12th question.
Very good question. Very good. Tejasvi, just remember, I was only approximating where that pi by 4 will be. See, up to 0 to 1, up to 0 to 1, up to 0 to 1, the greatest integer value will be 0. From minus 1 to 0, the greatest integer value will be minus 1. So I was only trying to locate where is this pi by 4. This pi by 4 is slightly greater than 0.75 and minus 0.75 is slightly less than, okay, minus pi by 4 is less than minus 0.75. So just to have an approximate to decide how I can take the greatest integer value, for that purpose I do. Otherwise, why should I take 0.75? I hope you got my point. Yeah. Is there any question on this again?
No, sir. No, sir. You
Okay.
can go on.
Yeah, fine. Good. Thanks, Akhilesh. You are making this session very interesting. You are helping me quite a lot.
Thank you, sir.
Yeah, fine. Here is something very interesting question. F of x is equal to x plus 1 whole square. X is greater than or equal to minus 1. G of x is a function whose graph is the reflection of the graph of f of x in the line y is equal to x. Then what is g of x? This is a very conceptually testing question. See, suppose if you are having something like this, you all know, students, this is the line y is equal to x. Suppose there is a graph like this. This graph is y is equal to f of x. So its reflection in this, if you take, then this is the graph of y is equal to f inverse x. So if you have an invertible function, the graph of f inverse x will be actually the mirror image in the line y is equal to f of x. This concept nowhere you would have learned in your NCERT book. I'm just telling you. So therefore, what is happening? G of x is a function whose graph is the reflection of the graph of f of x. That means your f inverse of x is g of x. So if you have to find g of x, you have to simply find what is f inverse of x? So your f of x is given to be x plus 1 whole square. Let us say it is equal to y. So your x plus 1 will be equal to root y. So your x will become root y minus 1. So what is x? F inverse of y equal to root y minus 1. So therefore, your f inverse of x is equal to root x minus 1. This is your g of x. So your answer is this, D option. Well, I hope the students are convinced.
Yeah,
Yeah.
sir.
Yes.
There are no questions, sir.
Yeah, very good, very good. Manoj sir, it's like this, the number of sessions is in fact less for us, but still we'll try to do the justice. Whatever we teach should reach out to the students properly. And the little number of questions that we've questions, even though we discuss, will definitely reach them, and that will enable them to solve many more in the material that whatever we have given them. Well, the domain of the function f of x is equal to root cos x. Domain. So once again, students normally get confused with domain and range. What are the values permissible for x? We call it as domain. What are the values that f of x can take? That is called as range. See, if you want this f of x to be defined properly, this cos x here, because it is root cos x, this cos x must be greater than or equal to 0. Now, if you want this cos x to be greater than or equal to 0, so it will be in the first quadrant, or it will be in the third quadrant. Fourth quadrant. What is that fourth quadrant? 3 pi by 2 to 2 pi. So that means in the first quadrant it is positive, and in the fourth quadrant it is positive. So you can't, is this the answer? Yes. Is this the answer? Yes. Will this be the answer? No. Will this be the answer? Yes. So how can there be three answers for this? The most appropriate is this, the D answer, and not these two. In the absence of this D, this particular answer, whatever is given there, if that option were not given, then you would have chosen either A or B. Since they are given both, what are that? The union of 0, pi by 2 and 3 pi by 2, 2 pi. The appropriate answer would be this D itself. I hope you are convinced. Let's go to the next one. Yeah, here you should observe we have been given two functions, f of x, g of x. Find the domain of f plus g. When domain of f plus g is given, so that will be the common domain for f and g. So
Excuse
that
me, sir.
means,
Sir, there are some questions raised by attendees. Sir, most of the students, they want a repetition of question number 17.
okay, done. Done. Yeah. I just wanted to know if all the students do follow Kannada also to certain extent, but DSU tells that the medium of instruction communication should be only in English. But once again, I'll see, my dear student, this is a very simple question. No need to get confused. So you have been given f of x is equal to root of cos x. We want the domain of f of x. When we want the domain of f of x, and since it is root something, whatever within the root is there, this should not be negative for us. If this function has to be defined properly, this within the root, whatever that we have, should not be negative. That means it should be greater than or equal to 0. So that means your cos x should be greater than or equal to 0. So greater than or equal to 0 cos x means it is in the first quadrant and it is in the fourth quadrant. Correct. So in the first quadrant, it is from 0 to pi by 2. In the fourth quadrant, 3 pi by 2 to 2 pi. So that means you have to take this and this. So that means 0 comma pi by 2. Okay. Union 3 pi by 2 comma 2 pi. I hope now it is much more clear.
So there's a question
Ah.
from an attendee
Ah.
that why can't we consider it as complex number?
Complex number cannot be considered because we are talking about real functions here. F of x is equal to root cos x. So unless otherwise mentioned, all functions are real functions. So therefore, we cannot consider complex numbers here. I think you're answered now.
Yes, sir. We can move forward, sir.
Yeah, please. No issues. We can go first today, no? Little slow will be going. Still, we have got a lot of time.
So one more question is now there, like from Miss Bhargavi. How to find range for the same function?
How to find the range for the same function?
Yes, sir.
It's very simple. What is the minimum value of f of x here? The minimum value of f of x is 0. And maximum it can go up to 1. So therefore, the range becomes just 0, 1. See, cos x, minimum value is 0, maximum value is 1. So therefore, f of x, what is that? Its minimum value is 0 and maximum value is 1. Over, that's all. Yeah, I think no more questions on this.
No, sir.
Yeah, fine. Now you please take this f of x, the 20th question. F of x, it's given as half minus tan pi x by 2. If you observe this domain will be minus infinity to infinity. All values x can take from minus infinity to plus infinity. Tan pi x by 2. X can take any value from minus infinity to plus infinity. Now, if you take g of x, this g of x is given to be root of 3 plus 4x minus 4x squared. Okay, let me make something little working here. See, this I'll write it as 4x squared minus 4x minus 3. Let me take this also, minus 4 into x square plus x plus 3 by 4. I think no, no, I made a mistake here. Just a minute. Yeah, it is x square minus x minus 3 by 4. So this will be minus 4 into x square minus x plus 1 by 4 minus 1 by 4 minus 3 by 4. What is that I am doing is the completing square. So minus 4 into x minus half whole square minus 1. So I think this g of x can now be written as 2 into 1 minus of x minus half whole square. Now, please observe, if this g of x has to be defined properly, every one of you, please observe. I do not want to repeat this again. So therefore, I want you to concentrate. See, please observe, this g of x I have expressed like this. This function has been expressed like this. Now, if g of x has to be defined properly, then your x minus half, please observe, this x minus half should lie between these two values. What is that? Minus 1 and plus 1. Do you agree? Let me ask this question, interpret. Have you followed, please? Any difficulty? Before I proceed, I just wanted to take a feedback from the students.
Sir, not for the question number 20th. There is one question for question number 19.
19 again.
Yeah, sir.
Let me complete this and go to 19 again.
Yeah, sir.
Yeah, please observe this, a g of x has to be defined, then this x minus half should be numerically less than 1. It has to be lie between minus 1 and plus 1. So then what will happen here is minus 1 plus half less than or equal to x less than or equal to 1 plus half. So therefore, this will be minus half less than or equal to x less than or equal to 3 by 2. So you are having minus infinity to infinity, this function defined, which one? F of x. And this g of x will be defined if it is lying between minus half and 3 by 2. So this whole thing is contained in this. So what is the overlap? The overlap is this, minus half to 3 by 2. So therefore, I can say that it will be minus half to 3 by 2 must be the answer. That is the D option, minus half to 3 by 2. Why did we choose this? Because F plus G means it should be the common domain. What is the domain of F? What is the domain of G of X? Both we find. And what is their intersection? Intersection means the overlapping region of their domains only will be considered. Yeah, well, I can, okay. Let me go
Sir,
back to,
there are some questions for question number 20. So on process, sir, you can just clarify that out.
okay. Then I'll go to 17 again.
Yeah. Sir, there is a question. Why should it lie between plus 1 and minus 1?
Very good. Very good. Good question that you have asked. Alas, suppose if I put root of 1 minus x square. So in this, if x square is greater than 1, it will become root of negative number. If x square becomes more than 1, it will be negative number. So therefore, what we want is this number, what is that? X minus half whole square should be less than 1. So if x minus half whole square is less than 1 means that x minus half must be lying between minus 1 and plus 1. Then only this 1 minus x minus half whole square, this whole thing will become non-negative. So therefore, if this g of x has to be properly defined, this has to be non-negative. If this has to be non-negative, that means this x minus half must be greater than. For example, instead of this 1, it is 9, let us say. Instead of, then what should happen? Then this x minus half must be lying between -3 and +3. That is how we take. So root of 1 minus half x minus half whole square, if that has to be properly defined, that has to be non-negative, then x minus half must lie between -1 and +1. So now we are finding what are the values that x can take. It will be lying between minus half and 3/2. And for this is the what is that domain. And for this g of x, the domain is this. And what is common for both these? What is common for both these is this, minus half to 3/2. So that will be the common domain.
Sir, next question is what is the range of fx and how?
What is the range of?
F bracket x and how?
Oh, this one. What is the range of this function?
Yeah, sir.
Very good, very good, very good. This half is a constant function. Okay. Now, why you are having about range? Range will be again tan. Now, this is a constant. This is tan function. Tan function always minus infinity to plus infinity it can take. So therefore, the range is minus infinity to plus infinity. So, my dear students, as far as possible, try to ask me those questions which are related to the question under discussion. So here we are only talking about domain. So in this question, we are not talking about range. So therefore, at this point of time, let us confine ourselves to the question what we want to do. Okay. Don't ask about what is the range of g of x, what is the range of this. We are only talking about domain here. In some other problem, when range comes, we'll address it. I hope I can go to the next one.
Sorry, sir. There are more questions about this same question.
Okay.
So, sir, Mr. Vivek HS has asked the question like minus 4x bracket x square plus x minus 3/4 can be in second step in side work.
Side work. Yeah. I have done the completing square here. Just observe, please. Vivek,
Okay, sir.
what I have done is this 3 plus 4x minus x square is there. Now I have written it as minus of 4x square minus 4x minus 3. Okay. Then I have taken that 4 also common. Minus 4 into x square minus x minus 3/4. And this x square minus 3x minus 3/4. I am just making it as a completing square. I think you have done it even in while doing integration. So what we do, half the coefficient of x, we square, add and subtract. So half the coefficient of x means minus half. Minus half that you square, add and subtract. So this x square minus x plus 1/4 will become x minus half whole square. And you know minus 1/4 minus 3/4 is minus 1. This again has been written in this way. 2 into root of 1 minus x minus half whole square. I think from there I have given the explanation. I think only this area you had a problem.
Sir.
Yeah, I think it's clarified. Please say yes.
Sir, there is one more question.
Sir,
so Mr. K. Prajwal is having a question that sir, should we consider common domain even for x type of questions also?
Common domain, if it is f plus g or f minus g, etc., we consider only common domains. Common domains means intersection.
And also, Mr. Srinath.
Yes, sir.
You can also advise the student to send the doubts through their mail so that we can discuss more questions.
Yes, exactly.
Yeah. Please,
Yeah.
Anikesh, please take care of it.
Yeah, sir. I will, sir.
Please
Yeah,
advise
yeah.
them to send it through mail also. We will address it later.
Sure,
Yeah,
sir.
correct. Now, one or two critical questions.
yeah.
If there are more number of people asking,
Yeah,
let
right.
us make it interactive. No issues.
Yeah.
Huh?
Okay.
No problem.
Okay, sir.
Only thing
Sir, there
is,
are three more questions.
uh,
Sir, Mr. Aditya Singh is asking that, sir, I have understood why it should be lesser than 1, but can it be greater than infinity?
if a number is less than 1, it has to be, if it's less than 1, how can it be greater than infinity? Okay, it's an irrelevant doubt. Okay, fine. Fine. Let us do something very, very important. Let's come back. As soon as I complete this particular segment, I will definitely discuss more questions, revisit. Well, a set A has got 4 elements and set B has got 5 elements. The number of injective mappings, when I talk about injective mappings, number of that is 1 functions that are possible. Now, so it's something like this. We are having 5 elements here. So let us say 4 elements. A1, A2, A3, A4, and another set B is having the elements, say B1, B2, B3, B4, B5. This is A and this is B. My question is the number of injective mappings that can be possible. How many 1 functions can be possible? See, whenever injective mappings has to be done, first thing is this n of B must be greater than or equal to n of A. First condition. If this happens, okay, if the number of elements in set B is more than the number of elements in set A, then the number of injective maps or 1 functions, okay, will be equal to, that is n of B P n of A. What does P means? Permutation. So therefore, in this case, it will be 5P4. So 5P4 means 5 factorial divided by 5 minus 4 factorial. So this will be 5 factorial. And what is 5 factorial? You must be knowing it is 120. So kindly note down this. So if we are talking about number of injective maps, set A cannot have less than the number of elements in B. So number of elements in B should be at least the number of elements in A. Then you can use this formula. This is straight away a shortcut taught to you. I think I can go to the next problem.
Sir, there are 2 questions
Yes,
for
please.
this question.
Yes, please.
If n A larger than nb,
Oh, n of A is larger than
n of b.
Suppose if you are having something like this, let us say you are having 1, 2, and you are having A, B, C. Okay. What happens is, whatever that no, if n of A is greater than, correct? No. Suppose if it is like this, then there can't be any what is that? There can't be a 1 function at all, because no element in A must be left out. So therefore, if the number of elements in A is less than the number of elements in B, then there is no 1-1 function possible. Good question somebody has asked.
Sir, no, okay, sir. The same question is repeated again.
Okay. Then leave it. Okay, fine. Here is a question. F is a function from R to R defined by f of x is equal to x to the power of 4. If you observe this, x to the power of 4, it is x to the power of an even number. So if it is an even number, then it can't be 1-1 because f of -1 is 1, f of 1 is also 1. So it can't be. Then next is, since x to the power of 4 happens to be a non-negative number, then in the domain, the negative numbers will not have pre-image. So therefore, this function is not 1-1. This function is not onto. So I think I leave it to you. What is the answer? That means f is neither 1-1 nor onto. The answer B is correct for this. It's a very simple question. Let us not spend more time on this. Yeah. The one more question, the similar question somebody asked me sometime in that 17th question or something. Here f of x is given to be root of 9 minus x square. So here, this x square should be less than or equal to 9. No, but we are talking about the range of this function. We are talking about the range of this function. So therefore, what we can do here is, let me not write like this. You have been given, what is the minimum value of f of x? When x is equal to 3 or minus 3, your y value will become equal to 0. When suppose x is equal to 0, your y value will become maximum 9. 9, not 9, root 9, it will become equal to 3. So is 0 accepted? Yes. Is 3 accepted? Yes. So therefore, it must be the first option, 0, that is for the values that x can take between -3 and +3, your y will lie always between 0 and 3. So this is the range. This is the domain. Okay. So values taken by x, domain. Values that can be taken by y, we call it as range. So therefore, the first option is the correct answer. Next, please. Yes. Here, you have been given two functions, f of x and g of x. So f of x is given to be mod x plus x. G of x is given to be mod x minus x. Now, f composite g of x is being asked. So this is f of g of x. So this is f of, what is g of x? See, if you observe this g of x, it is mod x minus x. And it's given x should be less than 0. So if x is less than 0, please note, there's a little tricky question. When x is less than 0, mod x will be minus x. So therefore, I'll write this as minus x minus x. So this will be f of minus 2x. Now, I want you to remember, if x is less than 0, minus 2x will be greater than 0. Correct? So, what is f of minus 2x? It will be mod of minus 2x plus minus 2x. Now, it's given that minus 2x is greater than 0 now. So, what is mod of minus 2x? Since minus 2x is greater than 0, mod of minus 2x will be minus 2x only. So, minus 2x. So, therefore, this will become equal to minus 4x. So, our answer is C. Before you ask me the questions, please go through this question once again. I want you to please look at this answer first. Get convinced. If you are having any confusion, you can ask me.
Sir, there are no questions. I think we can move forward, sir.
Yes, good. Are the students bored of asking questions? I don't know. This is again one shortcut I wanted to tell you. A has got 6 elements. The number of distinct functions from A to A. The number of distinct functions from A to A which are not bijections. See, A is having A to A. There are 6 elements here. Here also 6 elements. Please note. So, how many functions are possible means, see, the number of functions will be 6 to the power of 6 here. It's actually n of A, n of B, like this it should be. Power of. So 6 to the power of 6, this is the total number of functions. Now, I told you something like number of bijections means n of B, P, n of A. So how many bijections are possible? 6p6. 6p6 means 6 factorial by 6 minus 6 factorial, which is 6 factorial. Now, total number of functions is this, and number of bijections is this. So we want number of functions from A to A which are not bijections. So that means in the total 6 to the power of 6, I'll have to remove 6 factor. So this should be your answer. I am sure you would have followed this. Number of functions, this is the formula. Number of bijections, this is the formula. Number of functions minus the number of bijections. So we want the number of functions which are not bijections. So it will be 6 to the power of 6 minus 6 factor. The shortcuts, I do not want to give more theory into this. You can have to just remember this.
Sir, there's a question from Purnima RB. Sir, value of factorial.
Factorial. Okay, what is
Yes,
5 factorial means? It is 5 into 4 into 3 into 2 into 1. So it is 6 factorial means 6 into, that is n factorial means what? It is n into n minus 1 into n minus 2, like that up to 2 into 1. This is factorial.
Sir, there's another question.
Hmm.
Modulus of negative number will be positive number, na sir? By Ashwini Sajan, sir.
Correct, very good. See, for example, modulus of a number is the numerical value. If the number itself, see, for example, if x is less than 0, minus x will be greater than 0. If x is less than 0, minus 2x will be greater than 0. So as minus 2x itself is positive, so mod of positive number is positive number itself. I think this is where the confusion is. Purnima, I think I have addressed your doubt. Here minus 2x is positive. So mod of positive number is that positive. Yeah.
Yes, sir. We can move forward, sir.
Yes. Yeah, this is very good question. A has got 3 elements. B has got 6 elements. What can be the minimum number of elements in A union B? Let me get some responses from this, from the students. Let them type the answer, please. Let me see how many of them give correct answer. All the attendees, please write your answers.
Sir, first answer is 6
First
from
answer is
anonymous
many
attendee.
of them, they are given 6. Okay.
Yeah, many of the answer is 6. Mr. Niranjan Madhival says 9. Mr. Dhanush BK says it's 3. Sir, the answer is 3, 6, and 9. Most of the students are giving these answers.
Okay.
3, 6, and 9.
I would like to tell you that 6 is the right answer. How you know? See, suppose within this B, we are having A. Then A union B will be B itself. Okay. Suppose if A and B are disjoint, then A union B will be having 9 elements in it. So A union B, N of A union B can have from 3 to 9. So the minimum is, I'm sorry, the minimum is 3. I'm sorry, I made a mistake here. I should write it as 6 here. So in this case, if A is contained completely in B, then A union B will be having 6 elements of B. Okay, minimum number. Suppose if A and B, if they are disjoint, then this 3 elements and this 6 elements together, it will become. So the minimum answer is that 6. B option is correct. Most of you have given the correct answer. Okay, let's go to the next one. Yeah, this is on relation again. Define a function or on A 1, 2, 3, 4 x. X is related to y if x divides y. Then R is definitely it is a reflexive relation because 1 divides 1, 2 divides 2, 3 divides, so like that. Is it symmetric? Definitely not. Why? Because 2 divides 4, 4 doesn't divide 2. It's not symmetric. Then is it transitive? Yes. Divisibility. X divides y and y divides z means x divides z. So it is reflexive and transitive. There's a quick question. We should move on to the next one. This 34th. One comma 1, 2 comma 2, 3 comma 3, 1 comma 3. Then the ordered pair to be added to make it the smallest equivalence relation. Let me see what is the option. A, B, C, D is there. The student will type the answer A, B, C, D. Let me check who is going to give the correct answer.
Sir, most of them have answered A and B, sir.
Mhm. A, I'm afraid, is not the correct answer. B is the correct answer. Because if you include 3, 1, then 1, 3, 3, 1 is there. So therefore, this entire set becomes symmetric. Since 1, 3 is there, 3, 1 is not there, it can't be symmetric. So therefore, I have to add 3, 1. So if I add 3, 1, then it becomes reflexive, symmetric, and also transit. So the answer is this second option.
Sir, from an anonymous attendee,
Yeah.
said that thank you, sir, in Kannada for you.
ತುಂಬಾ ಸಂತೋಷ. ಥ್ಯಾಂಕ್ ಯು. ನನಗೂ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡ್ಬೇಕು ಅಂತ ಬಹಳ ಇಷ್ಟ. ಕನ್ನಡದಲ್ಲಿ ಪಾಠ ಮಾಡಿದ್ರೆ ಇನ್ನ ಚೆನ್ನಾಗಿರುತ್ತೆ. ಬಟ್ ವಿತ್ DSU we have agreed that we will speak only in English. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಇಂಗ್ಲಿಷ್ ನಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ, ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇಲ್ಲ. ಕನ್ನಡದಲ್ಲಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಪಾಠ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಇನ್ನ ಚೆನ್ನಾಗೂ ಪಾಠ ಮಾಡ್ಬೋದು. Others who don't follow Kannada, I have not taught any mathematics in Kannada right now. Please. Small
Sir,
clarity.
there is one question regarding the maths. What is the answer for 33 question? I had some network issues from an anonymous attendee.
Question answer for?
Question number 33. It's
okay. Yeah, that's what. Oh, for the set A 1, 2, 3, define a relation on the set A as follows: 1, 1, 2, 2, 3, 3, 1, 3. Then the ordered pair to be added so that it becomes, that's what the answer is, this 3, 1 only. If you add 3, 1, it becomes reflexive, symmetric, and transit. The answer is this B. On the set of all natural numbers, define the relation. A is related to B.
Excuse me, sir.
Sir,
Mr. Darshan Y is asking 34th question, how is it transitive?
How it is transitive? Okay, very good. Suppose if I include like this: 1, 1, 2, 2, 3, 3. Okay, 1, 3, 3, 1. Okay, first you are convinced that it is reflexive, and you know that it is also symmetric because R inverse is same as R. Then your transitive part I want to agree. See, 1 to 1, 1 to 3, 1 to 3 is there, 1 to 3 is here itself. Okay, now 1 to 3, 3 to 1, 1 to 1 is here. Suppose 3, 1, 1, 3, 3 to 1, 1 to 3, 3 to 3 is here. Over.
Yes, sir, we can move forward, sir.
Yes, thank you. Thank you. Okay, this GCD one, I want you to try this at home. Let me go to some other interesting problems, please. There's a question here called as the congruence modulo. So this congruence modulo means, I would like to give a little light because this is a new concept. This is not there in your NCET. So whenever we write something like this, A is congruent to B modulo M. The meaning is, this implies that M divides A minus B. This is the meaning of this. Now, is A congruent to A mod M? A is congruent to A mod M means M divides A minus A. A minus A. That means this implies M divides 0. See, in mathematics, you should remember every number divides 0. Every number divides 0 except itself. 0 cannot divide 0, or you cannot divide any number by 0, but 0 is divisible by every number. So here A is related to A according to this congruence modulo. So for every A is related to itself, therefore it is reflexive. Next, if A is congruent to B mod M, this implies M divides A minus B. This implies M divides B minus A. This implies B is congruent to A mod M. See, whenever M divides 2, M divides minus 2 also. So therefore, if M divides M, if see for example, 2 divides 4 means 2 divides minus 4 also. So therefore, if A is congruent to B mod M, B is also congruent to A mod M. So therefore, it is symmetric also. It is reflexive, symmetric. Then is it transitive? For example, A is related to B. B is related to C. So if A is related to B means M divides A minus B. This implies M divides B minus C. Now, you know, if 2 divides 4 and 2 divides 6, can you say 2 divides 4 minus 6 also? Yes. So, M divides A minus B plus B minus C. See, if 2 divides 4 and 2 divides 6, 2 divides 4 plus 6 also. So, if M divides A minus B plus B minus C, that means M divides A minus C. That means A is congruent to C mod M. So, that means A and C are also related. So, whenever A is related to B and B is related to B, A is also related to C. Therefore, we can say that it is transitive. So it is not only, so what is that? It is reflexive, symmetric, transitive. Therefore, the answer is this. It is an equivalence relation. I think you can forget this modulo because you have not been taught. It comes under number theory. I don't know if you have studied somewhere in school modulo, then it is okay. Otherwise, this is definitely a problem on relation which I have handled. Can I go to the next one?
Yeah, sir.
I think this formula I have given you the number of functions n of a to the power of n of b. N of a is 3 to the power of b. That is 1, 2, 3, 4. So 3 to the power of 4, 81. 3 to the power of 4, 81 is the correct answer. I have given you that formula, n of a to the power of n of b, number of functions. The total number of functions from a to itself is 2 to the power of 56. Then n of a equal to the number of functions from a to a means it will be n of a to the power of n of a. This is equal to 2 to the power of 56. So that means n to the power of n is 256. What is that n you can think of, please? Anybody who can give the answer? Quick.
Sir, 4.
Very good.
From Miss Sahana R. Kulkarni.
Very good. Very good. Very good. 4 to the power of 4 is 256. Then it means the answer is the C option. Very good. So now I think the students are able to like a bit of some shortcut, some formulae, etc.
Sir,
Okay.
Miss Monica Suresh is
Ah.
asking for the formula of 40th once again.
Enough A, enough to the power of enough. 3 to the power of 4. Over. How many attendees are there?
So we have 219 attendees.
Oh, good. Well, come to this 48th question. F is a function from n to n, where n is the set of natural numbers. F of x is equal to 3x plus 4. No, the options. It is actually not subjective, it is surjective, injective, both A and B, neither A nor B. See, if you observe this 3x plus 4, suppose if 3x1 plus 4 is equal to 3x2 plus 4, don't you get that x1 is equal to x2? Yes. If these two are equal, then you are getting x1 is equal to x2. Therefore, it is injective map. That is fine. Okay. Now, I don't know whether it is surjective. Now, f is a function from n to n. Now, there is a number called 1. Is this 1 having any association set from 3x plus 4? If 3x plus 4 is associated to 1, then x will become equal to minus 1. But minus 1 does not belong here. So that means what's happening, you observed that this 1 doesn't have any pre-image. So 1 is left out. So if 1 is left out here in the codomain, so that means 1 is not having any pre-image, means it can't be onto. Onto means what? Every element should have a pre-image, but 1 is not having a pre-image, so it can't be onto. So it is not surjective, it is only injective. I hope you have followed this. Yeah.
Yes, sir. We have very good smart students. They are answering before itself, sir.
Oh, very good. Thanks for the good feedback. Let me see. I'll give some time for this question. How many of them will answer? 49th question. F is a function from R to R. F of x is equal to x square plus x. Let me see. Let me wait for 2 minutes.
Excuse me, sir.
Yes, please.
Yeah, sir. Sir, we have got answers from students. The maximum count is of D and A.
The maximum count is D and A. Okay, very good. Okay, let me clarify here. F of x is equal to x square plus x. F of 0 is equal to 0. F of minus 1 is also equal to 0. So therefore, your first option of 1, 1 on 2 is wrong. It can't be 1, 1. So your second option is also wrong. So this is a many one function for sure. Now, the next question is it on 2? I hope the students are following. Have you observed that f of 0 is 0 and f of minus 1 is also 0. So therefore, two numbers cannot go to the same number. So if it goes like that, it can't be 1, 1. Next is, let me take y is equal to, suppose if f of x is, if it is equal to minus 1, what will happen? Suppose that means x square plus x equal to minus 1. X square plus x plus 1 equal to 0. Now, please observe, you have studied quadratic equations. X square plus x plus 1 equal to 0. What will happen to b square minus 4ac here? B square is 1 minus 4, which is equal to minus 3 less than 0. So therefore, no, not possible. Which is not possible? X square plus x plus 1 is not equal. So that means x square plus x cannot be equal to minus 1. So f of x cannot be equal to minus 1. So here, this minus 1 doesn't have any pre-image, even though it belongs to this R. We have seen that 0 goes to 0. Minus 1 also goes to 0. So this is not 1, 1. And minus 1, we have seen at least one element which doesn't have a pre-image. So therefore, it can't be on 2. So therefore, the answer is many 1 into is correct. D. So congratulations to all the students who have given D as the correct answer.
So there are 24 students who gave answer as D.
Very good. Very good. Somebody has given the wrong answer is also fine for me. I accept your, what is that? I appreciate your attitude of answering the question. Instead of remaining silent, you have attempted and you have given an answer. So that is to be appreciated. Okay? Your
Sir,
way
there
of,
is one question from
Ah.
Swati Katigar. What is many one function?
oh, not 1, 1 is many one function. Not on 2 is into function. Yeah. Now, I throw open this session. We have got another 15 minutes for the question and answer sessions. Today's class, if you have any doubts, you can ask me.
Sir, one anonymous question is there. Sir, I did not understand how into in last question.
Oh, how it is into. Okay.
The last question.
Okay, very good, very good. I'll explain once again. I think the student has understood that it is not 1, 1. See, in f is a function from R to R, there is -1. There is no number which is associated to -1 here. I mean, there are many numbers which may not be having any association, but my observation is this x square plus x, if it is equal to -1, if, then x square plus x plus 1 is equal to 0. So if x square plus x plus 1 equal to 0, that means this x will be either omega or omega square. Both are complex numbers. But complex numbers is not there here. Omega and omega square are not there here. Where this omega and omega square are not here. So only omega and omega square only can go to -1 under this definition of x square plus x function. So -1, there is no number which is associated to -1. So this -1 is left out in the codomain. So if -1 is left out in the codomain, at least if one number is left out, then it can't be onto function. It has to be an into function only. Are you answered now?
Sir, there is one question. So can you explain what is equivalence relation?
Oh, okay, want an explanation now. Okay, fine. See, you must be knowing what is reflexive relation. So reflection means for every A comma A belongs to R, then we call it as a reflexive relation. Symmetric relation means if A comma B belongs to R, this implies B comma A also belongs to R. Transitive relation means if A comma B, B comma C belongs to R, this implies A comma C also belongs to R. If all the three happens, then we call it as an equivalence relation. So equivalence relation means it has to be reflexive, symmetric, and transitive. Any other question?
Yeah, sir. Sir, someone is asking for the formula list for this chapter. So, sir, they can find it in the material. So,
Not in the material.
yeah.
Formula list is available even in the net. You want it, I'll share it. If not the formula list, a complete synopsis that can be sent. We didn't want to make this as very voluminous. We just thought we'll give you some PDF. That's more than sufficient because this 10 hours of teaching, 10 sessions of mathematics, 20 to 20 hours of teaching mathematics with some good questions, clarification of all the doubts, repetitions, and again plus a detailed synopsis is very difficult to cover the entire portions. Anyway, we can send. You'll have to wait for some time. We'll send the synopsis also. No issues. Yes. Any
Yeah,
other
sir.
question?
Yeah, sir. Next question. So, what about questions on binary operations?
Very good. Yeah. I thought I'll discuss it in the next class. Binary operations. Yes. I'll discuss it in the next class when after doing this sets. Okay. I'll do that. Sets, inverse trigonometric functions I'll complete. In that, while doing that, I'll do the binary operations also. That is also in this included. Yes, we shall do it because today it was not possible to discuss binary operations. Also, we'll discuss it in the next class. Surely.
So, Mr. Ashok has a question. So, what is GCD in question number 35?
GCD.
Yes, sir.
See, GCD means this is the greatest common divisor. See, what do you mean by greatest common divisor? Suppose I take two numbers. For example, some 24 and say 32. What are the divisors of 24? 1, 2, 3, 4, 6, 8, 12, 24. 32, if you take, what are the 32 divisors? 1, 2, 4, 8, 16, and 32. So I have listed the divisors of 24 and 32. Among that, the common, if you take 1, 2, I think 4 is common, 8 is common, that's all. So among these common, please observe that this 8 is the GCD of 24 and 32. There's a property about this GCD. Suppose if 8 is the GCD of 24 and 32, every number which divides 24 and 32 is also dividing that number 8. Correct? For example, every number which divides both 24 and 32 means you take 1, 2, 4, and 8. In that 1, 2, 4, and 8, every number will divide 8. So therefore, this 8, we call it as the GCD. So I have explained to you what is the concept of GCD. Now you talk about what is that? If GCD of A and B is 2, then R is reflexive but not symmetric, symmetric only, reflexive, and symmetric. See, the GCD of 24 and 32 is same as the GCD of 32 and 24. Correct? So therefore, it is symmetric. If GCD of A and B is 2, can GCD of A and A also is 2? What is the GCD of the say 24 and 24? The GCD of 24 and 24 is 24 itself. So the GCD of A and A is 2 only. So it can't be reflexive. It can't be reflexive. It can't be transitive also. So it is only symmetric only is the correct. The GCD of A and B will be same as the GCD of B and A. GCD of A and A can't be what is that? Same thing. So it is only symmetric only. Yeah. Any other question, please?
Yeah, sir. This is an for 20th question.
20th.
Yes, sir.
Yeah, I think somebody was asking about the 20th long time back.
Yeah, from that time to that.
Yeah. I'll address it now, please.
Yes, sir. So the question is, it's
Hmm.
given that for f
Hmm.
f bracket x comma x should lie between -1 and 1, but why did sir take it as infinity to infinity?
Correct. Good question you asked me. Good question. Yes. We are talking about the domain, right? Yeah, very good. Yeah, the domain is actually, yeah, it's given as -1 less than x less than 1. Correct. You're right. I'm sorry for this. So that means it is not this. I think I made a small mistake. I'll rectify it now. So it should be -1 and +1. Again, for g of x, what happens is, oh, this one will not be here. I'm sorry. This one will be here. Oh, let me redraw this diagram. Mistake. Thanks for asking this doubt, whoever it is. Yeah. See, you're having, oh, this should not be shaded. -1 to 1. Okay. What about this? -12 to 3/2. Oh, what is the overlap is this only. So it should be -12. Okay. Comma this one. Yeah, I think it is the C answer is correct. Yes. Who is that student, please?
Sir, it was anonymous actually.
Okay, fine. Yeah, I think I have made a small correction here. I didn't observe this particular thing, this -1 to +1. So if the domain for f of x is this, then we have found the domain of this g of x. From this, the overlapping region becomes like this. So the answer changes. So it should be this, the third option. Oh, thanks for correcting. I think we're almost, it's time up, I think, 10 o'clock.
Yeah, so
Yes. My dear students, I hope you did enjoy this session today. This was the first session. So maybe you are not used to this type of MCQs. I have done my best to cover all types of problems, especially the functions and other things. And I could not get into the binary operations, which I'll cover it in any of the sessions. Okay, so I have carefully chosen some problems where some complicated problems and some simple, a mix of everything. So that, and the previous year question paper or the problems also will be covered in due course. Anything that you wish to add? Anybody? Any comments? Shall we wind up this session, please?
yeah, sir.
Yes, sir. How will I wind up this?
Sir,
Hmm.
give me a minute, sir. I'll just. So there are
Yeah.
some questions again.
Okay. I
For
can
how?
till 10:30 till the next teacher comes.
Sir, actually, it's break time for them.
Okay. Let them take a break.
Yeah, sir.
Stop sharing. Yeah.
Okay, sir.
Stop sharing. Then leave.
So students, right now you have a break from 10 to 10:30 a.m. After that, you will be having your second class.
Bengaluru, that counts as the third top startup city across the globe, opens up a new and exciting opportunity for all innovators to come on board at the Dayananda Sagar University. Founded by late Sri R. Dayananda Sagar and late Dr. Chandrama Sagar, Dayananda Sagar Institutions is into education and healthcare for over 6 decades. DSI is today considered a center of excellence in producing students with exceptional academic skills and leadership qualities. DSI is now headed by Dr. D. Hemachandra Sagar and Dr. D. Premachandra Sagar. This leadership has successfully managed and excelled in ensuring excellence in all of its offerings. This great foundation ensured DSI to be invited by the Karnataka state government to set up a private university in the state. DSU could be among the very few campuses in the country to have a well-planned startup village that houses innovation labs supported by industry leaders. DSU provides a platform to visionaries and inventors to experiment their ideas. Globally reputed MNCs that include Autodesk, Bosch Etas, IBM, GE, VMware, NVIDIA and Boston, Bosch Rexroth, Dassault Systems are now part of the DSU initiatives. These companies have invested vast resources to create a one-of-its-kind facility to be used by the community. Joining this great movement is the support from industry bodies, Indian Electronics and Semiconductors Association, Manufacturers Association of India, and Indian Institute of Science in Bengaluru. The Startup Village will now receive guidance from Arizona State University, Rochester Institute of Technology, and Illinois Institute of Technology, Chicago. With a reputation for innovation, are strong backers of the DSU initiatives. Distinguished individuals from industry, academics, research, government are lined up to mentor each of the entrepreneurial ideas to ensure good ideas. A bouquet of specialists on call, patent lawyers to accountants, costing and taxation specialists, company secretaries, procurement engineers, bankers, designers, packaging specialists, logistics experts is one more feature of the DSU campus. Every year, groups of individuals enter the DSU portals with a burning passion and a dream to achieve. With the combined support and resources at their command, they are now sure to walk out of the DSU campus as owners of the companies enlisted on the National Stock Exchange and a university degree. The ecosystem created by DSU can now accommodate 300 enterprises and welcomes the community to take advantage of this great option and work towards making India a strong manufacturing nation. For passionate and innovative youth, Bengaluru is the place to be. And presenting
Dayananda Sagar University. Live the dream.
So dear students, we have our next lecture. We have our next lecture at 10:30 a.m. which is physics by Professor Satish. So please join by 10:30 again. Please have your breakfast, and if anyone wants notes and materials, you can go to the given link on the screen. Thank you.